Okay, so I will start off with the class. Okay, so in the last class, we were studying about the incremental model in the software development lifecycle models. We were studying about the incremental development model, and there we saw that successive versions is added and incrementally it is added. First, the module, the core module is made, then the non-core modules are made. So first, suppose A is made, it is coded, it is tested, and then again B is made, and then I am clubbing B with A. Again, the whole A with B is tested. Then I am clubbing C with ABC. Then again the whole ABC is tested. So, so two very good advantages are there when it comes to incremental model. The first advantage is the error reduction. Now it is very much obvious that if I am checking your copies and if I check your copy one time and suppose I give you some marks 10, and if I check it another time, it may happen that few steps where I haven't marked you, I may think later that if I give you some grace marks, it would be better. So I will give you +1 marks. So like this, if you go on checking the things a lot of times, so it's very much obvious that the chances of error is reduced to a great extent. So the core modules, since first the core modules are made and then the non-core modules are made, so core modules are those functionality modules which are necessity for the app or the service or the product, the first necessity thing. So since the core modules are used by the customer from the beginning and therefore these gets tested thoroughly, so this will reduce the chance of errors in the core modules of the final product. So the reliability of the software will be increased. Now, second advantage is incremental resource deployment. What is that? I will tell you. Okay, so incremental resource deployment, what this means that suppose the need for the customer to commit large resources at one go for the development of the system, it is not there. Suppose the developing organization, that organization will save a large number of resources from deploying them, a large manpower for a project in one go. So what happens is if I am appointing 20% at one go throughout the project, so those who are appointed for the testing, they are getting halted due until and unless those appointed for the design is getting finishing their work. But here what happens is every module, module A, module B, module C, every module requires the design phase, the testing phase, the coding phase, the and all these phases. So what happens is the persons involved in A, all the 20 persons are involved in A. Again, they can be involved in B. And first, when the design phase of A is complete, that person can switch and start the design phase of B. And when the testing of A is complete, that person can switch and start the testing of B. So what happens is a large manpower is saved with a smaller manpower also, since the modules are created in incremental approach with a smaller manpower also, this entire thing can be done. Okay, so these two are the major advantages of this incremental development model, and these two advantages was not there in the earlier other models. If we aim at giving a product to the client which has the least error, the client, it will be beneficial for them. And also, if an organization can give the same output with a lesser number of manpower, that means their cost will be less. So again, it is a great beneficial to the organization. So as a whole, the project becomes beneficial to both the client and the organization who is developing. So this is the first model which was seen that it is a very advantageous model in comparison to this classical waterfall, iterative waterfall. Then there is a V model, then there is prototyping model. With respect to all these models, this model is a great advantageous. Okay. Now, the next model which we will study is evolutionary model. Okay, wait a minute. Okay, okay. So, this model has many features of the incremental model. Suppose in case of incremental model, the software, it is developed over a number of increments, and at each increment a feature or a function is implemented and it is deployed at the client side. So the software which we were getting as a byproduct of this incremental model, it is a successively refined and function enriched, because few functions are there in A module, another few functions are added in B module, another few functions are added in C module. So like this, it is a function enriched until the full software we are getting in hand. So the principal idea behind this evolutionary layer model is somewhat similar to by the incremental model, and its concept can be understood from the name itself, that is evolution. So in the incremental model, what happens is complete requirements are first developed and the SRS document it is prepared. But in contrast to that, in the evolutionary model, these requirements, plan, estimate, solution, they evolve over the iteration. So what happens is, okay, so the concept is same. 1 minute. So the concept is same, like in incremental model also. Each and every iterations, new features were added. Here also, the thing or the model or the product, it will develop, it will evolve. But one basic difference is in the incremental model, the requirements or whatever I will say, the requirements, the plan, the estimations, they are frozen in the first slot itself, that is the requirement analysis and gathering phase. It was done only once. The requirements were frozen, the requirements were fully defined, and after that only the development iterations will begin. But here, from the requirement and planning phase only and the estimation phase only, everything is evolving. But in the incremental model, for the first time, all the requirements, the planning, the estimations were done in the beginning, and it was freezed. And the development activities, they were carried on in iterations. But in evolutionary model, the entire thing will be carried on in evolution or in iterations. So such evolution, it is a definitely a consistent, like with the, like suppose if there is some unpredictable discovery or there is some changes that take place in the new product or something, so they can always evolve, they can always adapt with the new changes. Okay, so even if it is an extension of the waterfall model or the extension of the increment model, but evolutionary model incorporates a major shift in the idea or the widely, suppose the all the adopted life cycle models till date, and in this recent life cycle developed models, they have changed a huge paradigm in the idea that this evolutionary software development process, the concept is design a little, build a little, and test a little and deploy a little. So the concept is, okay, so this is the concept. The concept is थोड़ा थोड़ा करके करेंगे, एक साथ सारा चीज करने नहीं जाएंगे. We will design a small part, we will build that part, we will test that part, we will deploy that part to our customer. If they are satisfied, fine. If they are not satisfied, then we will again rework. And then for the next model also, we will design that part, build that part, test that part, deploy that part. So each and every time we will evolve, we will do the evolution step by step, that after the requirements have been specified, the design, the build, the test, the deployment activities, they all will be iterated. So on incremental iterations, they all will be done. So if I need to draw the diagram to represent it better, so now I will draw the diagram. Okay, one thing. Okay. So Pooja is there, right? So why are you so late in joining the classes? So make sure from next time I am letting you in, but if it is crossing 10 minutes, I won't be letting anyone in. Being a student, if you cannot join in time to a class, then it's better you should not, you should leave studying. You should sit back at home and enjoy your vacation. Okay, so let us first draw this thing. Okay. So I am not drawing the boxes because since I am using a digipen, it will not be exact like I am able. So these are all enclosed in boxes. Okay. So what is this? First we get the specification, then we identify which are the core models, which are the non-core models, and we start developing it. First we develop the core model, then we collect customer feedback, and then we modify the requirements which are needed. Then we develop the next feature, and again we deliver this thing for customer feedback. So at each and every step, the new version or the next version of the software is added and it is delivered to the customer for checking. So like this, after several versions in incremental manner, it is evolved and it is checked by the customer, and finally we have the product in hand. And when all the features are complete, at this step, when all the features are complete, we give the product for maintenance, for use and maintenance. Okay. So this is the uh, design approach, or if I would say the graphical pictorial representation of how this evolutionary model is done. So if I talk about the advantages, the first advantage is from the customer point of view. Now each and every, like the first block of customer, before developing the whole product, we don't generally give it to all the customers, right? But we have a section of customer who we always test my product with. So the first good thing is this customer, they get a chance to experiment with this partially developed software before the complete requirements are developed. So therefore it helps in understanding the requirements accurately. It helps in processing the requirements of a customer with the help of the feedback obtained on delivery of the partial or the different versions of the software to the customer. So as a result, what happens is the change requests after the delivery of this complete software, it gets reduced. Okay. So the request to change the product entirely or major features after the final delivery, it will be reduced, because each and every version we are offering, or we are giving the unfinished little versions, we are giving it to the customer. They are checking, they are testing, they are using, they are giving the feedback. If they want some change requests, they are saying, we are incorporating those, again we are delivering. So what it will reduce, what it will reduce this act which was happening, that a major changes need to be done when finally delivered to the customer. So this will help in reducing that feature. And obviously, since I am giving versions in incremental approach to the customer, so handling this type of change request, it is easier, as long-term plans are not made over here. Short-term plans are made, because if I am giving module A, they are saying okay, giving module B, they are saying okay, giving module C, they are saying not okay, then I will identify that some problem is there in module C only. And if I make module A, B, C, D and then give it to the customer and they say a change is made, I will have to first identify which module is creating the problem, or after incorporation of which module the customer is not satisfied. So obviously a large amount of rework is reduced. So since change requirements are always smaller in comparison to the large change requests that may come at the end when I am producing or providing the software as a whole at one go to the customer. So obviously handling the change requests, it is better. So the first advantage which we studied is what? For first advantage is since feedback is there, so it reduces the change requests after delivery of the entire system, because at each and every step we are changing if change is coming from the customer. And then again, in addition to this, handling the change requests, they are always easier because we are using incremental approach. Okay, so this is the entire concept about evolutionary model. Anyone has any problem in understanding? Is it clear to you? Someone please ask.
Yes, ma'am.
Okay, someone please write to your group, to Sudhir and Deepak, that they won't be allowed to enter because they wanted to enter after 20 minutes the lecture is happening. So I won't be allowing anymore. I have done enough for the previous classes. I won't be allowing that. Okay. But if I only talk about advantages, it is not true. There are a few disadvantages also associated with this evolutionary model. The first disadvantage is this feature where I am saying that incremental parts will be coded, incrementally things will be done. So what happens is, for small projects, maybe it is true. For smaller projects, I can divide it into separate modules and I can start working on that. But for larger projects, it may generally the scene is a lot of modules, they are intertwined with each other, and so they are dependent on each other also. So even if an expert comes to divide it into incremental parts, even if he is successful in doing that, but for doing that, a considerable effort is needed to plan and to deliver the incremental deliveries. So this incremental delivery, it is not good for large projects. So this is one disadvantage. And another is, suppose at a time that design is done, that design is done only for the current increment where this increment is done. So each and every time, again, that this design concept, I have an entire design which I am planning in the first place itself, and then each and every time with each and every successive increments, I am again designing, I am again implementing, I am again designing, I am again implementing. So first of all, it is time consuming. Second thing is that if I constantly do that, it may differ from the design which I first started with the design that is documented in the SRS document. So there can be a mismatch between the two things. So again, these designing issues, it is a problem. So these are the two basic disadvantages, but these disadvantages are not so strong in comparison to the advantages they give. Okay, so evolutionary model, they are normally used for large projects where it is easier to find modules for incremental implementation. Okay, so when the customer prefers to receive the product in increments so that he can start using the different features as and when they are delivered, rather than waiting all the time for the full product to be developed and delivered. So for those cases, this evolutionary model is helpful. Okay, and another feature is, for object-oriented development, for object-oriented software development design, object-oriented software development design, this evolutionary model comes of great help, because here this is the programming approach where we can divide our entire concept into several classes, several methods, several objects. So for object oriented software development projects, evolutionary model is very much applicable, because it is easy to partition the software into several standalone units in terms of the classes. Okay, and classes, they can be more or less developed independently. So for object oriented software development projects, this evolutionary model comes into hand. Okay, so this was the concept about evolutionary model. Is there anything is there any problem in understanding till now? Is
No,
this
ma'am.
concept clear? Okay, first I will share with you the.
Yes, ma'am.
Okay, so everyone please mark your attendance. Do not share this with your friends who are not present in the class, because I have got 4 to 5 people who are trying to mark, or you are trying to enter after like 2 minutes back, after 30 minutes of the class has passed. So do not please help them, because this is not helping, this is ruining your friend's life also. So everyone has marked their attendance, right? Is there anyone who has not been able to mark his or her attendance?
Ma'am, one sec.
Okay. So I will stop the share, and if there is anyone left who has not been able to mark his or her attendance, you people write your name in the chat box. Those 2 to 3 people, I will give your attendance manually. Okay. So the next topic which we will learn is the RAD model. What is this RAD model? Rapid Application Development Model. Okay. So this RAD model, it was proposed in order to overcome the rigidities which was associated with the waterfall model. The first rigidity or the major rigidity which was associated and which was needed to make a huge change is difficulty to accommodate any change requests from the customer. So a few radical extensions to the waterfall model was proposed, and this model, it has the features of both prototyping and evolutionary model. So it has the feature of both prototyping and evolutionary model. Okay. So in case of evolutionary model, it has a similarity that it follows the evolutionary delivery model to obtain and to incorporate the customer feedbacks on the different incrementally delivered versions. The different customer feedbacks are incorporated. So this portion of the evolutionary model where I can have feedback from the customer and I can incorporate those feedbacks in incremental versions of the software. This feature of the evolutionary model, it took. And in case of prototyping model, this model had the mixture of making the prototype. So prototypes are constructed and incrementally the features are developed and delivered to the customer. But unlike the prototype model, what used to happen, can anyone say, once in prototyping model, we were developing the prototype, we were giving it to the customer, and after the customer has said okay or not, what we were doing with the prototype? Anyone, please, what we were doing with the prototype? We were keeping the prototype or we were throwing away the prototype?
Ma'am, throwing away the prototype.
Throwing away the prototype. So in case of prototype model, what used to happen is prototype is thrown away, right? But that feature in RAD model is not there. So from the prototype model, it only took the feature that prototype can be made, prototype should be made, and from the evolutionary model, it took the feature that incrementally the feature will, or the functions will be developed and it will be delivered for feedback to the customer. And if the customer gives any change requests, we will incorporate those, and incremental versions we will again be delivering. So one feature of prototyping and another feature of evolutionary, both it took the good features of both the models, it took, and it developed a RAD model. Okay. So remember this, in prototyping model, after the prototype have been created and tested, it is thrown away. But this feature is not taken in RAD model. In RAD model, the prototype is kept because prototype itself is changing with incrementally after adding a few features, the prototype is changing. Okay. Now this gives us a few uh, goals of this RAD model. The major goals of this RAD model. Okay. The first goal is obviously it will decrease the time taken and the cost incurred in order to develop the entire software. It will decrease the time and cost in order to develop the software. The second goal is like these are the goals. Goals mean this RAD model aimed at to decrease the time and to decrease the cost which was taken in order to develop the software. So these were the goals for building this RAD model. The second goal was to limit the cost of limit this cost of accommodating the change requests. So with each and every change request needs to be incorporated, a cost is associated. So this model aimed at reducing the cost which was associated in accommodating the change requests which was coming from the feedback. And the next goal is to reduce the communication gap between the customer and the developer. Removes the communication gap between the customer and the developer. So each and every step, the developer used to give the partially made product to the customer. The customer used to check, he used to give feedback, then again he used to give the partially made product. So a concept